It's a challenge when we talk about developing apps for cross-platform use. And here we're talking about the top 3 operating systems being iOS, which is your iPhone, iPad, Android phones and tablets, and Windows phones and tablets, either Windows 8 or Windows 10. Traditionally, when we would develop for these platforms, we would create what was called native apps. And to do so, we would use a language that is specified for that platform that would tie into all the APIs and the platform system itself. So for iPhone, iPad, we would use Objective-C, and more recently Apple has suggested developers move to their new language called Swift. And that's what we're teaching here at South Mountain, is the Swift language. On Android devices, we would use Java, and on Windows 8, traditionally we use C#, although you can do it with Visual Basic. Now, aside from the languages themselves, you also have to learn the tools to work with these languages. And so we have 3 different set of tools, what we call integrated development environments, IDEs. On the Apple side, we have Xcode. On the Android side, we use Eclipse with Java or the newer Android Studio. And on the Windows side, we're using Microsoft Visual Studio. These give you the fastest compiled apps that are available on these systems. They're accessing the APIs or the application programming interfaces on these devices, and therefore can access all the device features such as the GPS, the accelerometer, and so forth. And they give the native look and feel. The IDE tools, when you create a button in Android Studio, looks like a button that belongs on an Android device. And they're store ready. So you can package these and deploy these to the iPhone store or the Google Play Store for Android or the Windows Store for Microsoft. But here's the big negative of this. If you want to do cross-platform development, you've got to learn 3 different languages and 3 different IDEs. And in essence, you're developing 3 separate apps. That's very time-consuming. Most companies would probably have teams that are developing on the iOS side, teams developing the Android side, teams developing the Windows 8 side. And then those teams have to communicate. And so that takes more time to communicate what's happening between these different apps. You've got to get everybody on the same page. And as changes take place, you've got to communicate with all those 3 teams. Of course, it means increased development time and more money in the long run. And if you want to make changes to these, you have to go back to those 3 separate apps and update each one of those. Again, that's costing more money and more time. So a popular approach is to use what we call web apps. These are apps that exist on the internet, and they're created with HTML5, cascading style sheets, and JavaScript, the same tools that every web designer uses to create websites. And so now we can create apps that are accessible by these 3 devices and run in the cloud, saving some storage space on the device. And the nice thing is you develop once. All 3 of these devices can access the same web app. We're using the skills that web developers already have, and there's lots of tools and resources available for creating these apps. Now they're web-based, which can also be a negative. So the positive is we're saving storage space on the phone. The negative side is you've got to be connected to the internet to use the app, and your phone has to load it each time, which makes it slower. Now there are ways to take your HTML5 web apps and wrap those with something like Cordova and deploy those to the store and have them install and run locally. The negatives are, obviously we need to be connected to the internet, and they are slow. They're interpreted. They're not compiled. They typically don't access the APIs, so you're not going to access, say, the accelerometer of the device if you're creating a game. It doesn't have the look and feel of the device. So it looks and feels like a button on the internet, not a button on an Apple device or a button on an Android device or a button on a Windows 10 device. And each of those buttons look different. There's a different culture for each one of these devices. As I said, they're not ready for the store unless you wrap them, which adds additional size to the app itself. And they're not great for heavy processing. They're great for informational things. So if you want to create an app that's going to advertise a company, maybe the menu for a restaurant, a web app's a great way to go. It's not heavy processing. And it gives you the flexibility to easily modify that. People don't have to download updates to get the most recent information. It's always available. Another way we can do cross-platform is a framework approach. And my favorite is the Adobe Air framework using Adobe Flash. I've been a Flash developer for a long time. I really like developing in Flash and using the ActionScript language. I think it's fairly powerful. I love the animation aspects. And this framework approach of using Adobe Air is still really popular for creating games on these devices. Now, you may have heard you can't run Flash content on an iOS device or even an Android device. And that's true. You can't run Flash content that's on the web, but you can take Flash content and produce it for the Adobe Air framework, and the Adobe Air framework can be installed on both those devices and make your game accessible. The number one game a couple years ago on iOS was Machinarium. That was created all in Flash. Now on the Windows side, there is not an Adobe Air framework for Windows 8 or Windows 10 apps, but you can run Adobe Air in Flash on the desktop side of, say, a Windows 8 tablet like the Surface Pro. Again, the positives here: you develop it once. Flash developers can use their existing skills and their ActionScript knowledge. They're store deployable. So in Adobe Flash, you're creating an APK file that can be sent to an Android device, uploaded to the Google Play Store. And they're great for animation-heavy apps. Again, just great for games. The negatives are the framework adds additional overhead, and you can actually embed the framework in the app itself. My suggestion is you probably want to load the framework and then load the app on top of that. And as with web apps, they don't have the look and feel of the device. They look and feel like more like a web app. But for games, that's usually not a big issue. And this brings us to another approach to creating cross-platform, which is shared code. And here we're using a framework approach also, but it's shared code in that Xamarin is a fairly new tool that allows us to use the C# language with Visual Studio or their own Xamarin Studio and create apps for all three of these platforms that really are native in their approach. They access all the APIs and so forth, and they can be deployed to all the different stores. Each of these apps share a piece of code, which is your business logic, and that greatly reduces development. They have the native look and feel. So if I create in Xamarin, I can create 3 separate interfaces for each of these, or I can use something called Xamarin Forms and create one interface that all 3 use. But in creating that one interface, when it builds for each of these platforms, it makes the controls look like the controls for that platform. So if I create a button in Xamarin Forms and I deploy it to iOS, it'll look like an iOS button. But if I deploy it to an Android device, it'll look like an Android button, and the same with Windows 8. C# is a very powerful language, and by using it as the back end for these platforms, we also have access to the .NET framework and all the capabilities that C# brings with it, such as JavaScript object notation, JSON, web services, collections, threading. Anything we can do in C# basically we can do for these devices. Now we're learning one language and one IDE to create all 3 platform apps. Now the negatives are Xamarin's kind of pricey. It's $1,000 annual currently. The good news is there is an academic license available, and students can get this for free. With the one approach of creating interfaces for each one of these 3 platforms, it can be a little time consuming, but you save a lot on the back end as far as your logic code. But you can use Xamarin Forms, which is still a little bit buggy. It's kind of new and it's kind of limited on what it can do. But if for a fairly simple interface, you don't have to customize anything, and using controls that are common to all 3 of these platforms, Xamarin Forms is a great way to go, and you're developing your interface once. The other drawback to this is there's fairly limited learning resources available. The best one that's most up to date, and Xamarin is constantly changing, so a lot of resources are out there, but they're not the most recent stuff. Xamarin University is probably the best choice for learning to program in Xamarin, but it's pricey. It's $2,000 for an annual subscription. If you want to become a Xamarin certified developer, you have to go through Xamarin University. There's just no other way to do it. The best thing you want for your resume is a nice portfolio of projects that you've published to the different stores. And being certified is not that important in this industry. So let's talk about creating apps in Xamarin. So we have our three devices, and the typical way is we're going to use Xamarin iOS and Xamarin.Android. We're going to create a view, which is our interface for each of these three different platforms. There are going to be some platform-specific code, and the assets, such as the icons and graphics and things that we would use, need to be sized for that platform. But most of your logic code, the view model, and we're using an MVVM pattern here, model, view, view model pattern. The view model is your shared code. You're writing it once. And there's two ways we can do that. We can do that with portable class libraries, in which it creates a DLL, or we can use a shared asset project, which is going to link to all that code for each of these builds. So in Visual Studio, you have the option of creating a blank app native portable or a blank app native shared. And then all your data is shared. The model itself is shared across the platforms. With the Xamarin Forms approach, we're creating one view across those three platforms, and they are natively rendered. Again, so a slider will look like a slider in Android, it'll look like a slider in iOS, and so forth. There is still a little bit of platform-specific code to create. You still have your own assets, such as the icons. Any graphics you want to use need to be sized for each of these platforms. Your view model is still shared, but now we're going to create a Xamarin Forms portable. So we have the portable class library or the shared asset project. And in Visual Studio, we would choose one of these two options, depending on which way we wanted to go. And we'll discuss the differences between these two approaches. You have the blank app Xamarin Forms portable or the blank app Xamarin Forms shared projects in Visual Studio. And of course, our data is shared across the three platforms. So which approach? Should I use Xamarin Forms or should I use Xamarin.iOS and Xamarin.Android? I would say we want to use the forms when our apps contain universal controls. Each of these platforms contains buttons, labels, text boxes, sliders, and so forth. Those are controls that are universal across the platforms. You may have some things you want to do that are specific to the iOS platform or the Android platform. And obviously we can create Xamarin projects and not target all three platforms. We could create a Xamarin project that only targets Android or only targets the iOS side, in which case you'd probably want to use Xamarin.iOS and Xamarin.Android. So I'd also use those when you want to use platform-specific controls. If a common UI is important, then certainly Xamarin Forms would probably be a way to go. And if there's not a lot of platform-specific functionality, I would use Xamarin iOS and Xamarin Android when that functionality, that platform-specific functionality is higher, and there's interaction and gestures that are platform-specific. Each of these platforms are going to have their own culture and their own navigation procedures and their own gestures. Now, when you install these, there's a couple things you need to be aware of. So when we install on a PC, we're going to add the Xamarin extensions into Visual Studio. And in Visual Studio, we can create cross-platform projects that target all three of these, but there is one caveat, and that is Apple requires the project be built on a Mac. So you must have a Mac in your network that you can access, and your PC will link to it. So when it goes to build, it will send the code to Xcode on your Mac and build it there and use the simulators that are on your Macintosh computer. You can also use Xamarin Studio on the PC or Xamarin Studio on the Mac. Now, the drawback here is Xamarin Studio on the PC you cannot develop for iOS. And on Xamarin Studio on the Mac, you cannot develop for the Windows side. You can, however, create a Xamarin project in Xamarin Studio on the PC and then copy it over to the Mac and add in the Mac project, and vice versa. We can create it on the Mac and copy it over to the PC, run Xamarin Studio there, and add in the Windows side, or bring it into Visual Studio and add the Windows side there as well. So that's a brief overview of Xamarin. We'll get into setting things up and creating our first little Xamarin project in the next video.